All right, there we go. All right, you can see my whole screen still?
Yes.
Okay. All right, so this is one that might that could trip you up. I'm not sure because you might be tempted to divide both sides by 7. But when you're solving by factoring, you can't divide both sides because you'll miss one of the solutions.
Okay.
And when you're solving by factoring, you're always setting it equal to 0. Okay.
Mhm.
Okay. Um, okay. So we're going to do the same thing. We're going to subtract 56x. And it's equal to 0. You good?
Yes.
And factoring, again, we're looking at what it has in common, and we don't have to split it up like we did the last one.
Hmm.
So, are you able to look at 7 and 56 and see if they have a factor in common?
Not really.
Okay. So, with 7, the only factors of 7, do you know what I mean when I say factors?
Like multiples
I
or
don't know.
okay.
So, the only thing that multiplies to get 7 is 1 and 7, right?
Uh-huh.
So 1 does us no good because if I factor out a 1, this doesn't change.
Right.
So the only possibility for the numbers is 7.
Okay.
Okay. So then if 7 is going to work, then you're thinking, okay, 7 times what is 56? And if you don't have it in your head, which is fine, you just take 56 and divide it by 7 and you'll
Which
get
would
8.
be 8, right?
There you go. So that means I can factor out a 7.
Okay.
And what's the greatest number of x's these guys have in common?
1
Good.
or yeah.
Just 1. So I can only take out 1x.
Hmm.
And so what does that leave me from the first term here?
X cubed.
Excellent. And what does it leave us here?
No X.
Good. And what number does it leave?
56.
Well, we factored out a
Oh,
7.
8.
Yeah, there you go. Okay.
Hmm.
And so we have a row of multiplication. We got the 7x times this honky wonky thing in the parentheses. So that's
Hmm.
when we can use our zero product principle by setting them both equal to 0.
Okay.
Divide by 7. 0 divided by 7 is 0. We're going to add 8. X cubed equals 8. So to undo something squared, we took the square root of both sides, right? I'm sorry, did you hear that?
Yes.
Okay. To undo something cubed, we're going to, excuse me, we're going to take the cube root of both sides. And you might think, why am I not putting plus or minus in front of that? I'm going to tell you that in a second. Okay.
Okay.
The cube root of x cubed is x. That's the whole reason we do it.
Hmm.
And do you know how to figure out cube roots?
Um, I was just gonna type it on a calculator.
Oh, good. I didn't know if your calculator had it. I thought you had like the,
I believe I'm using my phone one right now, but I believe my actual calculator does. I have a fancy one because I had to have it for
right.
last semester. Um,
Well, it probably has something like this, the nth root of x, like that, something like that.
let me see.
X to the y, maybe something like that. And you would just make sure there's a 3 there.
Okay.
Or you just, a cube root is what number multiplied by itself 3 times equals 8. So you could just try out numbers. In this case, it's 2 because 2 times 2 times 2 is 8.
Okay.
3 times 3 times 3 is 27. So the cube root of 27 is 3. And so
Oh, okay, okay.
the cube root of 64 is 4 because 4 times 4 times 4 is 64.
I see, I see.
Okay.
Yes.
So we have two solutions, x equals 0 and x equals 2.
Mm-hmm.
Okay. So when you have an odd, this is called an index, the thing inside the radical sign here. So like for, if there's no index, there's actually a 2 there. We just don't write it, just like we don't write a 1 in front of an x or something. But there's actually a 2 here. Okay.
Mm-hmm.
Um, when there's an odd index, you do not have to put the plus or minus in front.
I gotcha.
And I'm just going to show you why. Maybe it'll help you remember. Um, remember, the cube root of 8 equals 2 since 2 times 2 times 2 equals 8, right?
Mm-hmm.
That's the whole reason um, it works like that. Now, the cube root of negative 8 equals negative 2 since negative 2 times negative 2 times negative 2, negative times a negative is a positive, times a negative is a negative.
I see, I see.
So there isn't a positive and negative solution for odd numbered indexes. It's either positive or negative, not both.
Okay.
Okay?
Yes.
Now, if I start explaining like why and you don't want to know why, then you tell me.
Okay.
Honestly, because the only reason I do it is if I it might help you remember, but if it's not going to help you remember, then we can just say, all right, if it's odd, don't put plus or minus. If it's even, put the plus or minus.
No, it definitely helps
Okay, cool.
because I don't really remember a lot of the rules or
Okay.
different things sometimes.
Well, I get it. I'm with you. All right.
So would the answer be two for the last
It
one?
would be 0 and 2.
Okay.
Remember, we got the 0 first?
Yes.
Okay.
So it would just be written zero and then comma two or
Yeah.
okay.
Well, if you're doing it by paper, if you just do what I did, your teacher is going to be fine if you just box them.
Okay.
Even if you don't do that, we'll find it. Does he usually have an answer line? Like
Um,
put your
I'm
answer.
not sure. I haven't taken a test from him yet.
Oh, okay. Well, I mean, you can do x equals 0, x equals 2. I would imagine he would take 0, 2.
Okay.
Um, I wouldn't worry too much about it. The only time you really have to, worry about it is when you're entering it online, because that's very particular, which is highly annoying. Uh,
Very.
or, well, it just makes me crazy because you enter something, you forget to put a comma and you get the whole dang thing wrong, and that's ridiculous.
Yep.
Or if your teacher is very, very picky about how you list your answers, which is also ridiculous.
No, he's pretty lenient. He was telling us today.
Good,
Yeah.
good, good, good. 'Cause I was going to write a sternly worded email to somebody. All right, so we got to solve this stupid thing. Okay. So ultimately, the goal of solving any equations is to get your x's on the same side of the equation and then get them all by themselves, right?
Yes.
Okay. And even though it took a while on these guys, we did do it, right? But
Hmm.
once we separated them out, then we got x's by himself. We had to do a whole bunch of horrific stuff before that, but eventually the goal was getting x all by itself. Okay.
Hmm.
All right. This looks impossible, but it's not. It's not. It looks intimidating, probably, because of the square root, and it's not just like the square root of 25 or something.
Hmm.
So remember how to get rid of a square root, I'm sorry, to get rid of something squared, we took the square root of both sides.
Yes.
Okay.
So that would you just like square the equation then?
Yay. So now
Okay.
to, but we're undoing, this is the opposite, if that's what you meant. To get
Yes.
rid of a square root, we're going to square both sides.
Okay.
Now, be sure you put parentheses around, if it's more than one term, be sure you put a parentheses around it.
Okay.
And squaring a square root, all that's left is whatever was under the square root.
Okay.
Be very, very careful here because, and don't write what I'm about to write. The
Okay.
temptation here, or the mistake that almost everybody makes at least once and many several times, is you say, oh, I just square each thing. It's x squared plus 49. That's not true.
Gotcha.
Okay. And the way to remember it is, or to help you remember it is, I'll just do like 8 squared. You can probably do in your head 8 times 8 is 64,
Hmm.
but you're multiplying 8 times 8 to get it, right?
Hmm.
So whatever is being squared, you're multiplying it by itself, even if it's a big, nasty parenthesis thing. So x plus 7 squared is x plus 7 times x plus 7.
And then would you like foil it?
There you go.
Okay.
So I'm going to work on it silently since knew what to do. And then when you're done foiling, stop and see if you got the same thing as I did.
I did.
Sweet. Okay. So again, we got to get our x's on, we got to get everything on one side and set it
Hmm.
equal to 0. Okay.
Okay.
And we got a squared. So anytime you have a squared or a cubed or anything like that,
Hmm.
you want to um, you really want to make sure that you keep the sign positive. Okay.
Okay.
So since it's positive, I'm not going to move it to the left because if I moved it to the left, I would have to subtract it, right?
And
And it
then
would
be
be a
negative.
negative.
Okay.
There's too much negativity in mathematics. Am I right, people? Thank you for laughing. That was pretty terrible. Okay. So, so what I'm going to do is move the 4x and the 33 over here.
Okay.
And what I like to do is when I do have like terms, I just line them up on top of each other. If you're okay there.
Yes. Would it be plus 30, I mean plus 16?
Oh, I thought I put it there. Thank you.
You're welcome.
Sometimes my pen's a little wonky.
You are good.
You're catching lots of good stuff. That's excellent. Okay, so now this is what you were thinking of earlier. This is factoring a trinomial, which means try three. It has three terms
Hmm.
and a squared. So now you are looking for factors of 16 that add up to 10.
Okay.
And that's where you do this thing. You have the x and the x.
Hmm.
And then you put those numbers here and here.
Where do I put, oh, okay.
So can you think of factors of 16?
2 and 8?
Add a girl. So we put plus 2 and plus 8. We could put plus 8 and plus 2. It does not matter.
Okay.
And then what are we going to do from here?
Um, do you set it to 0 or?
How we doing?
Good.
Well, we're not quite done. We got answers, but we're not quite done. Isn't that sad?
A little.
It is. Did you see this little doohickey here?
Mm-hmm.
Okay. Whenever you see that, they usually don't put that. Okay. The
Okay.
reason that it's there is in the original equation, we have a square root. Okay.
Mm-hmm.
And we cannot, the square root of negative numbers is undefined. You can't, it doesn't exist.
Okay.
Okay. And that is because, um, here, let me do this. So this is going to be our check. Square root of 4x.
And then you like plug it back in to see if it like gives you like a no solution type of thing.
So, well, we actually don't even have to do the right side. We just have to make sure that when we plug this in, we do not get the square root of a negative number.
Oh, okay.
Actually, no, I take that back. We do have to do both sides. We do have
Okay.
to do both sides. Okay. So we're going to plug it in and check. Okay.
Mm-hmm.
And just real quick, the square root of 4 equals 2 because 2 times 2 equals 4, right?
Yes.
The square root of negative 4, well, a 2 times 2 is a positive 4, and a -2 times a -2 is also a +4,
Okay.
right? And so there's
Yes.
not two numbers that are the same that we can multiply to get -4. I mean, I can take
Mhm.
2 times -2, but those are two different numbers, right?
Right.
So that's why it doesn't exist.
Okay, so the -2 option wouldn't exist, so it wouldn't be a solution.
No, 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 no. I
Oh,
was
okay,
just giving
okay.
you an example of why we can't take the square root of a negative number. It has nothing to do with this. I was just explaining why we have to check for this.
Okay, because if it was a negative number, then you get into like the imaginary type stuff, right?
Oh, I didn't know you were doing that stuff, you poor thing.
Yeah, unfortunately.
Oh, okay, so let's check her out. So this would be square root of 4 times -2 plus 33. And does it equal? I put a question mark because I'm checking it, but you don't have to
Okay.
if you don't want to. So so that checks.
Let's see. Okay.
So we know this is good, right?
Yes.
Okay, so now let's do -8. So this still comes out to 25, doesn't it?
I believe
Yeah.
maybe.
Yeah. Or nope. So we come down to the square root of 25 equal to -1. That's not true, right?
Right.
So -8 is not a solution.
So it would just be -2.
Mm-hmm.
Awesome.
Okay, so back here are the one you didn't send me. Oh, yeah, they did. So if neither of the solutions work,
You would
then
have no solution.
yeah, it would be the empty set. Or you could just, I'm confident you could just write no solutions.
Yeah, he said you can write no solution, n/a or none, just as long as it's not a solution.
Oh, get creative, say nada, like ain't nothing working, sir.
That'd probably give him a laugh.
I did all this work and there's no solution. You got to be kidding me. If someone had done that in my class, I would, okay, that's 100%. I'm not grading anything else. That's fantastic. All right, so we're in the same scenario as before,
Mhm.
where we have a square root. But the problem is we have this annoying X guy with it.
Right.
And we have to square the square root to get rid of it, right?
Mhm.
So we want to get it by itself. Okay.
Okay.
The so we're going to get rid of that X. Okay.
Okay.
Now we're going to square both sides, but we have this negative here, so
Mhm.
it gets squared as well, but it's inconsequential because a negative times a negative is a positive. So it just goes away.
Okay.
Good riddance. And then let me know if you get the same thing as me. Oh, I didn't write out the steps.
And then like to do like the FOIL, the shortcut, he was saying something like um you like double the first term,
Oh,
like
yeah.
you it would be what like 3 times 3 and then multiply that again by 3 or something.
Um, what it is, and I'm feeling more confident with you just foiling it.
That's what I was just gonna do, yeah.
I would just do that.
Okay.
I can show you, but when it gets like this and the variable is negative, it just gets a little nasty.
Yeah.
What it really turns to is you square the first term, and then it's
Mhm.
2 times the first term times the second term plus the second term squared.
Yeah, I'm gonna stick to foiling.
Yeah.
But yes, I did get the same answer.
Excellent. Okay. So here we are, right?
Hmm.
And now what should we do?
Combine like terms?
Yeah, we don't have any on either side that are the same. Like the left side doesn't have like terms, nor does the right side.
Right.
So what should we do?
Well, you said something about like the x squared remaining positive, so add it to the other side first.
I'm so excited for you. Excellent.
And then I would do I would add the 6x to the other side
Booyah.
and then add the 11 to the other side.
No, no, no. We're moving everything over to the left side.
Oh, okay, okay. So subtract the 9 from the other side.
Yes. Now you can't, it's totally legal to add 11 to both sides, but
Uh-huh.
you would just have to move it back to be able to factor it.
Gotcha.
You can do whatever you want to both sides of an equation. We can multiply both sides by 1,000,000 if we wanted to, but but we're just creating more work for ourselves.
Okay, okay.
All right, now what?
Um, Factor?
Yeah.
So it would be what equals 20 but multiplies to 12?
Yeah, it would be negative 20 though.
Yes. Um,
So what I do when I can't think of it
mhm.
is I start with one because sometimes one works in this case
Uh-huh.
and list the factors like 1 times 20, right?
Okay.
2 times 10. Just start working your way up. 3 doesn't work, right? There isn't anything times 3 that's 20. And then 4 times 5, and we've exhausted it because we've closed the gap between the two factors.
Okay.
Okay. Now, the temptation is, oh, 2 and 10 is 12, right?
Mm-hmm.
But 2 times 10 is positive 20. We need it to be negative 20.
So one of them has to be a negative.
Correct. For any of these to work, right?
Mm-hmm.
So what you're actually looking for is when there's a minus here, is you're looking for two factors whose difference is 20. I'm sorry, is 12.
Okay.
So 20 minus 1 is 19. Nope. 10 minus 2 is 12. Nope. 5 minus 4 is 1. Nope. So it could mean there's no solutions.
Mm-hmm.
Did you learn the quadratic formula?
Unfortunately.
That
Yeah.
is a good answer. That's a really good answer.
Yeah.
Okay, so we can't factor it. So then we're going to
Mhm.
have to use the quadratic formula.
Oh, okay.
Okay, so do you remember it?
Yes. Can't, oh, I'm gonna write that down. Can't factor. Um, so x equals negative b plus or minus square root of b squared minus 4ac and then over um 2a.
Kind of girl. So what's my what we'll start left to right. What's B?
12x?
Not BX, just the
Oh,
12.
just the 12. Okay.
So I don't know if this helps, but I'm going to put a caveat in here. I got to use the word caveat. I feel smart. Okay, so 4,
How come you wouldn't include the x into it?
okay, so here's the caveat.
Mm-hmm.
A x squared, bx. B is the coefficient,
Uh-huh.
right? B is the number in front of the x. It's not the x because we
Gotcha.
don't put x's in this formula, do we?
No.
So it's just, do you know what I mean when I say coefficient?
Yes.
Okay. Plus or minus 12 squared minus 4. And do you see that A is 1?
Yes.
And we got calculator work or arithmetic.
And then 2 over. Okay.
I'm going to scroll up for a second.
Okay.
Urgh. So a negative x times a negative x is positive x
Whoops.
squared. So we actually have to move everything to the right side of the equation. But
Understood.
we did get practice using the quadratic formula. Now, if for whatever reason you're unable to factor it, maybe it
Hmm.
is factorable, right? But let's just say you couldn't figure out uh, this one, right?
Uh-huh.
The quadratic formula always works for all of them.
Okay.
Okay, so you can always fall back on this. Okay.
Good to know.
Now, if under the square root is negative, right? Let's say you worked this out and it's a negative. Remember, we can't take the square root of a negative number, it's undefined.
Yes.
There are no solutions.
Okay, okay.
Okay. So I'm so sorry, but we're gonna redo this part because this is positive. It just goes, to show you, you got to be, as you know, one little silly error and you're going to get the whole dang thing wrong. However, just what you have told me so far about your professor,
Hmm.
I think, and maybe you know this or not, I think that he would take a point off for the negative and then give you credit for doing the rest of the question correctly, but with the one wrong step. Does that make sense?
Yeah. No, that's he says as if make sure you show your work because you can always like earn points back if even if you get the question wrong.
Mm-hmm.
And he was saying how some equations he's going to ask us to find like the perfect square or factor to find it, but if we don't do those things, then he take off like a point or so, and each question's 5 points.
It sounds like a wonderful, I like this guy.
Me too.
Yeah, that's good. All right. So now we're going to move everything to the right side because the squared is positive. Okay.
Hmm.
If you're okay with where I'm at.
Yes.
Okay. So now we need factors of positive 20 that will combine to be negative 12. And so when I write out these factors, I don't worry about the signs of them. I just write the factors, and then I'll worry about the signs when I start thinking about this.
Okay.
Because there's too many combination, like positive, one could be positive, 20 could be, there's too many combinations.
Hmm.
Okay. So when we multiply these, we have to get a positive 20, but when we combine them, we have to get a negative 12, right?
Right.
Well, if this is positive, the signs have to be the same, right?
So
Either
two
both
negatives.
yeah, could be two negatives. And then do you see what we're going to be able to do here then?
Yes.
What's that?
So it'd be -2 and -10.
That's what I'm talking about. Are there a lot of people who are sick at your school?
Yeah, I was out all last week with the flu.
It's everywhere.
Yep, I've never had the flu before and I managed to get it.
I was like we're in an Airbnb in Toronto and
Uh-huh.
we're in a basement apartment and the mother and daughter And we've been here for 3 weeks. They have been coughing steadily for 3 weeks
Oh, wow.
from this flu. Thank God we haven't got it. And then I was in Oklahoma this weekend doing a
Hmm.
doing a workshop, SAT, it doesn't matter. And um, it was a small little town. Half the schools are closed.
Oh,
They don't have enough teachers and subs,
that's crazy.
isn't it?
Yeah.
Okay. So what do we got a square root and they warned us, right?
Yeah.
So we gotta check them, don't we?
Yes.
Isn't math so much fun? I mean, there's just so much to do. You're never bored. I just love it.
Not my cup of tea.
You know, I invented sarcasm.
Yes. Awesome.
You get it?
Yes.
From what I'm hearing from you, um, it sounds to me like you're getting it.
Yeah, much more. Yeah.
And and your confidence, well, you're still asking like, do I do this? Like sometimes. Um, but you haven't said anything wrong yet.
Ooh,
So anyway, I'm just saying, you can have confidence.
I appreciate it. I was wondering if we could do this problem and then look at absolute value. I think I sent a few
Sure.
um, equations in there.
Okay. Yuck. Give me 1 second.
Okay.
I just want to look at something real quick. Where did you go? I'm thinking of a complicated way, and so I'm just looking real quick because I don't want to do that to you. How's that?
Perfect.
Okay. Oh, blah blah blah. I don't like that. You know what? Let's go to absolute value because I don't want to spend time um thinking about it because it's just too complicated what I'm thinking about. So let's go to the absolute value ones.
Okay.
Okay. Oh, that looks like fun. I'm opening all of them until I get to the absolute value.
You are good. Thankfully, we have like a test review uh and stuff, and they're not as hard as some of these problems on the homework.
Oh, good.
Yes.
All right, here we go. Get out of there. What happened? I got rid of my, oh, there it is. Okay. Okay. And so we're meeting tomorrow too, right?
Yes.
Okay. Um, so absolute, first of all, do you know what absolute value means?
Not off the top of my head. I have an idea, but not really.
Give me the idea, unless you just don't want to.
Um, how do I explain it? I don't know how to explain it, but I know,
It comes out positive.
yes, and it has to be positive.
Yeah, that's what I was looking for. That's fine.
Okay.
So what absolute value actually means is the distance from zero on the number line. Okay. So, we have five. Well, that's easy. Five is 5 units away from zero, isn't it?
Yes.
Okay. -10. Well, -10 is 10 units away from zero, right?
Mm-hmm.
No one ever says like, how far is that? How far away are you from that wall behind you? No one says, oh, -10. It's behind me, so it's negative, right?
Uh-huh.
Distance is always positive. So that's what absolute value is for. It's the
Okay.
distance from zero. Okay. Which means there is always the possibility of a positive and a negative solution. Because if I should get this out of here because I don't want it to confuse you, like it's part of the problem if you look back. So I had this like 0, 5, -10. The absolute value of -10 equals 10. Absolute value of 5 equals 5. Distance from 0.
Okay.
Okay.
Mm-hmm.
So if I have something like the absolute value of x is equal to 3, well, the absolute value of 3 equals 3, and the absolute value of -3 also equals 3, right?
Right.
Meaning x could equal 3 or x could equal -3.
Okay.
Okay. So to be able to solve that equation, what we would do is to account for the possible negative solution, we drop the absolute value and we say x equals 3 and we negate the other side of the equation.
I see.
Okay. So we have 2x absolute value of 2x minus 3 equals 7. So this is quite friendly um, because we drop the absolute value and we do both possibilities.
Gotcha. Okay.
So after that, not too bad.
Whoops, I forgot to do a -7.
Don't do that.
Okay.
All good?
Yes.
All right. Okay. Why does that go away? Oh, I know why.
So would the second equation stay like the 2x minus 3, or would it be 2x plus 3?
No, you only change the sign of everything on the right side, on the other side of the absolute value.
Okay.
I shouldn't say the right side because the absolute value could be on the right side. So everything on the opposite side of the absolute value, you change the sign,
Okay.
right? Well, you leave it alone and then you do the negative of it.
Got it.
Okay. Now, in order to do that, you have got to get the absolute value all by itself.
Hmm.
Okay, so here we got a pesky 7 out in front of the absolute value. And the temptation might be to multiply the 7 through, because if we had 7 times 2x minus 5, that's equivalent to 14x minus 35 by if I multiply through by 7, right?
Right.
Can't do that with absolute value. So that is 7 multiplied by the absolute value, but we just get rid of it like we would in a normal equation. We would divide both sides by 7.
Okay.
And then we're off and running.
Wait, is this another problem?
Yeah.
Oh, I was so confused. I was like, wait, how did you get, because they were like the same exact numbers.
Yeah.
That is my fault.
Nah.
Okay, now I'm on the same page.
Oh, do you need a break?
Oh no, I'm good.
Okay. All good with this one?
Yes, I'm just working it out really
Oh, okay.
quick.
Sorry.
No, you're good. Now I'm good.
Wait. Okay.
Did I give you any imaginary numbers by chance?
Um, Probably.
Okay.
It's hard to tell because you have to work like just at a quick glance. Because sometimes you have to work it and before you can see it's going to be imaginary.
Right.
Okay, new problem.
Okay.
So we're going to subtract 7.
Hmm.
And so this is where it could trip you up. Okay. Yep. Are you to here?
Yes.
Okay. So back here, once we got here, we're like, okay, one's positive, one's negative, and then we solve away, right?
Uh-huh.
And remember, what does absolute value mean?
Positive.
It's positive, correct?
Yes.
So we have got absolute value all by itself.
Okay.
Over here, we have a negative 4. So it's impossible for anything within an absolute value to come out as negative, correct?
Correct.
That's not possible. So it's at that point you would have to realize there's no solution.
Okay.
Now, the other way, well, if you can remember this, um, if you can remember this, your life is a little bit easier. You'll have more time on the test because
Mhm.
as with solving any equation, you can always check it by plugging your solutions back into the original equation and see if it makes sense, right?
Right.
So like back here, oh no, let's do one that was sort of easier, like this one. So x is 5, 2 times 5 is 10, minus 3 is 7, the absolute value of 7 is 7, right?
Hmm.
2 times negative 2 is negative 4, minus 3 is negative 7. The absolute value of negative 7 is 7, right? So,
Hmm.
so you know these are correct. I was trying to save you from having to check these just to save you some time. Same thing's true here. Um, these are both going to work
Okay.
because, like, if you see a negative, then you can immediately um, say, oh, there's no solution, then you don't have to check your absolute values.
Right. Okay.
Does that make sense?
Yes.
So that's a choice for you. Um, because as long as it's positive on the other side, the solutions are good.
Okay.
If it's negative after you get the absolute value all by itself, excuse me, if it's negative, then there's no solutions.
Got it.
Okay?
Yes.
All right, rock on. Okay, so, yep, that's a good one. So the fun continues. So we're actually doing the same thing, even though there's an absolute value on both sides. So we can't get a single absolute value all by itself on one side with just numbers on the other side
Okay.
when we have two absolute values. So it's actually the same procedure. We're going to keep the left-hand side as is by dropping the absolute value. We're also going to drop the absolute value here. And so our first deal is going to be 9x plus 12. Okay.
Okay.
And what did we do when it was just a number? Well, we did the positive one and we did the negative one, didn't we?
Yes.
Like we would have a positive 7. Like if this was 7 in here, this would have been 7, and then we would have done negative 7, right?
Right.
Okay. But we have a big old mean nasty algebraic expression. So we're still going to do the negative solution. We're just going to have to negate that whole dang thing.
Where did the 2x and the negative 2 come from? Oh, okay.
What? Maybe your eyesight is bad. You didn't see that 0. Thank you.
You're welcome.
Now, I'm not sure how you would like to do it. Like some people can look at that and instead of putting the parentheses, they'll immediately write negative 9x minus 12. You just change the sign of both of them. I like to do the parentheses.
Okay.
So whatever floats your boat. Okay, and then we're just solving away here, right? We got equations to solve, so you just
Would
solve
you
them.
do that step on both sides later on with the parentheses?
Oh, no, no, you don't have to do it with the 2x minus 20 as well. No.
Okay, okay.
You just have to do the right hand side. You'll get
Okay.
the same, if you did it, you'll get the same solutions.
Okay. And it would it be negative 9? Oh, wait. Oh, I see what I did. Okay.
Oh, nasty fractions come into our lives. Doing all right?
Yes, I'm good.
Okay. Ready to move on?
Yes.
Awesome. Okay. Okay, these are the radicals again, which I'm going to get back to this next one. So I'm going to move down to your next set. Okay, so here's some inequalities. Okay. Woohoo. Okay, so solving inequalities, we solve exactly the same way we do regular equations,
Hmm.
as long as there's nothing like squared or cubed or something like that. But if it's just
Okay.
plain old x's, then we solve them the same way we do other equations, with one exception. And that is if we have to multiply or divide both sides by a negative number. When that happens, we have to flip the inequality.
Gotcha.
Okay. Now this one, that's not going to happen. So, and subtracting from both sides, that's not multiplying or dividing. So you don't flip it when you subtract, only if you multiply or divide by a negative.
Okay. So like if I was dividing by a negative, it would be less than or
Yep,
equal to?
yep.
Okay.
You know, when you get there.
Yes.
Okay, so they say use interval notation to express the solution.
Uh-huh.
So I'm not sure what the options he gave you for interval notation. I'm hoping it was this. So for x greater than or equal to 7, actually we're going to graph it first. That makes the interval notation easier because we also have to graph it on a number line, right?
Okay.
So for x greater than or equal to 7, I just put the 7.
X would be infinity, right?
Not necessarily. I mean,
Okay.
x goes to infinity, yes. But x is any number from 7 all the way to infinity,
Okay.
because all of those numbers are either equal to or greater than 7. The
Gotcha.
one that's equal to it is 7, right?
Right.
Okay. So for the interval notation, what I'm hoping is he let you use brackets and parentheses.
Yes.
Yay. So we use a bracket if it's equal to, meaning that 7 is part of the solution,
Uh-huh.
and then to positive infinity. Infinity is never invited to the party. So
Right. So it has a parenthesis.
correct. Racism does exist because or infinity is excluded just because of how it looks. Okay.
Yes.
All right. All right, here we go. Okay. So, once you get here, let me know.
I'm there.
Okay, so we have a choice here. Um, my choice when I'm solving equations is I always like the x term to be positive.
Hmm.
So I'm just going to do it real quick, okay?
Okay.
And just show you why I might not do it this way. Actually, we'll do it both ways. Um, so I'm going to make the x positive over here, okay?
Okay.
So then we would have 6 greater than 36 plus 3x. Subtract 36. Let me know when you get to here.
Got it.
Okay, so the only reason this you might not want to do this is you have to wherever the variable is, you have to read it from that side. So I have to read this from right to left, and from right to left, that reads x is less than negative 10,
Right.
which we can rewrite. Okay,
Okay.
and then we're in business, right? That's fine. So, or if you like to keep your variables on the left-hand side, that's fine. It just depends on if you get confused reading right to left instead of left to right.
How
Which
come
one?
why would you switch the inequality sign?
Well, I'm really not switching it. If I was reading from right to left, the x is less than the negative 10 going this way.
Uh-huh.
So I just rewrote it, putting the x on the left. And
Okay.
I could read it left to right. That's all.
Would keeping it like the -10 first, would that be a wrong answer or?
It is not a wrong answer, but when
Okay.
you my concern is when you go to graph it or do the interval notation, it might be confusing. But
Okay.
this is absolutely correct
Okay.
as long
I
as you can graph it and write the interval notation.
I assumed it would be like a number line and then -10, like a plot at -10, then the arrow would go to the left.
That's correct.
Okay.
So let me show you the or,
Okay.
but seems like got a good handle on that. And I don't, it just depends on if you want to deal with negative numbers and this nonsense. So I'm going to keep the x's on the left this time. And what's going to happen is we're going to have to divide by a negative number.
And then you'd flip it
There
anyways.
you go.
Got it.
But x remains on the left-hand side.
Hmm.
So it's just, however.
I see.
The circle would be open though, right?
Uh,
On the
yes.
underlying graph, because negative
Yes.
10 is not invited. God, it just really burns my embers. And
Would
with
you,
interval, go
and then
ahead.
since the inequality sign is equal to, it would be parentheses all around, right?
Correct. Negative 10
Okay.
isn't invited. And with interval notation, you always, from left to right, you start with the least number.
Gotcha.
You good?
Yes.
Awesome. All right. Okay, if I don't do all the directions on there, it's just saying the same stuff. You ready for this one?
Yes.
Okay. I think we did something like this last time where we had fractions.
Yeah, then we canceled them out.
Yeah. Did you continue to do that?
Yes.
I wonder if he, um,
He does it as well.
oh, good.
Yes.
I like this man. So my question to you is, what are we going to multiply each one of these by?
18?
Very good.
I got the same thing.
Excellent. Um, does some professors or teachers insist that you put another number on the number line, usually zero,
Uh-huh.
instead of just the number, just to make sure the orientation is correct?
Hmm.
I'm not sure if your professor cares or not.
I don't think he does.
Okay.
Okay. Hey, Patrick. Yourself?
I got it.
Wait,
That's all right. I'm just at the door.
all right. Yay, compound
Yes,
inequalities.
no. Um,
Can wait, Grayson. Okay. All right. So with compound inequalities,
Mm-hmm.
um, I like to solve them at the same time. Um,
Okay.
I'm not sure what he did. Did he break them up into two? Do you remember? Like this?
Um, I think he just kept it the same.
Okay.
I believe this kind of threw me in a loop a little bit. I was like, because I last week I believe we went over this and quadratic formula and
Yeah.
I missed it.
Well, well, all you're doing is instead of splitting them up like this,
Uh-huh.
you're just doing it all at once. Like you're solving two inequalities at once by keeping
Oh,
it
I see,
together.
I see.
That's all that's happening.
Okay, and you just keep the middle term.
Yeah.
Okay,
So I'm going to subtract two everywhere.
got it.
It can get a little dicey, and I'm sure there's going to be one like that, but not terrible.
Yeah, you said whatever you do like in the middle or something you have to do on the other side.
Yep.
What if after the -5 that inequality was less than or equal to? Would the -7 be like filled in?
Yes.
Okay,
And then
I
the
see.
other one's not, and then this would be a bracket.
Got it. Okay.
Funny you should ask.
Okay, these aren't too bad.
No. They can go in opposite directions. I'm trying to,
Hmm.
you're okay with fractions?
Would you just cancel them out with this?
Oh yeah, you could. Well, here there's just one. Here, let's just do it.
Okay.
Yeah, you can do the same thing. Like, would you want to get rid of that?
What do you think would be
It's,
easiest?
I think we should be consistent. Let's get rid of it.
Okay.
Um, the only thing is if it was negative, like I would still just multiply through by positive, and then we'll deal with the negative later.
Okay. And you still multiply each term?
Everything.
Okay. And oh yeah, I see how it'd cancel out. Okay. Got it.
Sweet. Aha. Just when you thought everything was just lovely. All right, so we got absolute value in the house now, right?
Yes.
Okay, so it's the same idea with one little twist. So we're going to drop the absolute value and just rewrite it as is without the absolute value, right?
Hmm.
And then what did we do when it was just plain old equals?
I'd assume it would be a negative 14.
Good. But remember, you think of it like this. Remember how I said flip the inequality if we multiply or
Yes.
divide? So that's what's happening. So we got to change that to greater than.
I got it. That makes sense.
Okay, good.
Hmm.
Let me know when you get to graphing.
Yes, I'm there.
Okay, so I'm not sure if you can just see it from here and know exactly what's going to happen because there's like four different scenarios that could occur. Okay, so I just graph these separately to start.
Okay.
Like, so x less than 5 is that, isn't it?
Yes.
And x greater than negative 2 is this. Yes?
Yes.
So when they overlap, then the actual solution is what they have in common. So it would be this. This,
Okay.
so you might want to do scrap work and then do like a final thing.
Okay.
Because that might, I think he would be okay, but maybe just, I don't know, put it off to the side or something and indicate that what your actual answer is. I don't know. I think he would be okay as
I
long
think
as
so too.
somewhere you have this. Now, it could be, end up going in opposite directions. or the same direction. So I'm assuming we're
Mhm.
going to get some of those.
The answer choices are very interesting.
Yes, they're confusing.
Yes.
They didn't quite do it. Well, they did. The first one. Yeah, it's the first one. That's what we
Oh,
did.
I see. And then you'd plug in like the 5 or like the
Yeah,
-2.
correct.
Okay. That makes more sense now.
Yeah. So here we go again. Oh, decided we're going to get rid of the fractions.
Got it.
Right? So here again, we have to manipulate until the absolute value is by itself.
Okay.
I might rush through this just to get them in your notes.
No, you're good. I
Our
appreciate
time is
it.
up. So this is one where it's a little bit different. If you just want to stop and look real quick.
Yes.
Okay, so we have, these are the solutions as long as I didn't make an error. But x greater than 5, well, that's this way, right?
Yes.
And x less than -2 is this way. So they do not overlap, right?
I see.
Okay, so that's the correct graph. But interval notation will take care of this guy. Negative infinity to -2. Union, which means along with 5 to positive infinity.
Ah, so the union comes in. Okay.
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 All right. I will send you these and get the video uploaded as soon. I'll send you these right away, but the video will take a little bit.
Perfect. Thank you.
All right. See you tomorrow.
See you tomorrow.
All right. Bye.
Bye.